Good morning, everybody. How's everyone doing? Day 2, first thing. Congratulations for making it out. Who was out after it started early, 8 p.m. last night still? 9 p.m., 10 p.m., 11 p.m.? The hands aren't going down as quickly as I was expecting. Congratulations for making it to day 2. Thanks for coming to my talk and bearing the early traffic. I, myself, have only just made it. As you can tell, I'm still calming down from having just about got here on time by a cab, because the underground, as always, is more terrible than usual. I don't know how you can be more terrible than usual, as always. Statistically, that doesn't make sense, but it does to me, so we're going to go with it. But thanks for coming along. We're going to be talking today about legacy code bases and the challenges that we have when we inherit them, because that's always a fun prospect, isn't it? Who here identifies with let's not go straight for pain. Who identifies with the idea, to start with, of inheriting a legacy codebase? Whoa, that's like 100%. Who here thinks that there's an equal correlation between that and absolute pain? Whoa, 100%. Okay, let's see if we can fix some of that for you. Who am I? Why am I here talking today? My name is Ben. Hello. I've been a software engineer since 1999. I used to put the number of years down. I kept having to update it, and it made me feel sad. So I now have a fixed number in there. It's a constant now instead of a var. So I've been coding since 1999. I can't even say 1999. 1999, it's the Y2K bug right there. I started out in ASP.VB. Does anybody remember that? Visual Basic ASP? Oh, whoa, 1%. Yeah, it's ancient. Then I very quickly learned about PHP, which you might nowadays look at and go, oh, really? But in those days, it was the bomb, right? So I got into PHP, been doing front-end development as well since like the mid to late 2000s, done some architectural business analysis kind of stuff. So I've touched a lot of different projects. I haven't necessarily coded in every language, but I've probably touched most projects in most languages. I'm a very big fan of the developer and open source communities, hence I love being at events like this and catching up with people like you and finding out what your pains are and maybe either sympathizing with you and, we'll go for a coffee or probably a beer to talk about those. I'll be around all day and for the party tonight, so come tell me your woes afterwards as well. And a lot of the work that I do is around security and privacy. So while this talk isn't particularly security and privacy related, if you do want to see me get on a rant, just start any topic around that, and I'm like, do you even have time for me to start? I'm a developer advocate at Sonar. If you don't recognize, as you might recognize, Sonar Cube or Sonar Lint, which are the code quality tools that some of you might use. How many people here use a Sonar product? Well, it's like 80%. That's awesome. For those of you who didn't put your hands up, go to sonarsource.com, and we haven't quite got to sonar.com yet. But sonarsource.com, check us out. We've got a linter that just plugs into your IDE completely free, and it'll just help you write better code. And then we've got some backend services. There's a hosted version, Sonar Cube, and then we've got Sonar Cloud as well, which fits into your CI/CD pipeline. I'll touch a bit on that today, but that's all I'm really going to say about Sonar, because this is not a talk about that. But just in case you were curious about what they do. So yeah, those are the products. I'm on X, or as I like to refer to it, Twitter, because who here still calls it Twitter? I realized the other day when I was doing another talk, a lot of people still call it Twitter, and I actually like it because you know how there are certain people in the world who don't like to accept that some people want to be called by a new identity. I like not calling X by its new identity. It's kind of a little bit of a statement right there. So just sit on that for a bit, have a giggle, and then I don't think any of you will call it X again. You're welcome. All right, so let's get into the actual meat of the talk. So what is a legacy code base? Essentially, we've got intricate mazes, developer nightmarish kind of scenario. We've got complexities in the code itself. We've got lack of documentation. We've got situations where technological progress is basically hindered by the fact that you don't really know what's going on. And even if you haven't inherited this legacy code base, you've been part of the project for a long time, who else has been in that situation? Legacy code base that you've actually been part of from the beginning, and you get to the end thinking, how did we end up here? Yeah, right. There's somebody at the back who just suddenly put their hand up, and I'm not calling you out for that. I love the fact that you did, but it's like, oh yeah, that bit at the end, how the hell did we get here? You totally resonate with that one. Often when we look at this situation, we think to ourselves, okay, well, we've got this legacy app, it sits in this legacy hosting environment, we've got to keep it going there. What can DevOps actually do to help us around that, though? DevOps is a fairly new thing. I mean, it's not. It's been around for decades. But when it comes to applying that to legacy code bases, is there actually anything we can do in that, or are we always stuck in that situation where, you know, it's hosted in this particular way that MySQL was configured and on this PHP server and whatever? We'll go into some options of how you can take an application that seems like it's stuck in its ways and bring it into the 21st century. So who here is actually a PHP developer or understands any PHP? One. Oh, no. Oh, about 5%. Excellent. So this, if you're like me and haven't actually touched PHP for about 10 years, looks fine. For those of you who are not PHP developers or also stopped developing PHP about 10, 15 years ago, you will not realize that the constructor name is incorrect. We don't call the constructor after the name of the class anymore. We're using an old MySQL connection feature right there, and we've also hard-coded the host name. Now, this is code that I specifically typed for this slide, but it's the kind of code that I've seen before. I'm sure you have seen this as well. And this is the kind of stuff, when you look back at old code, you look and you think, like, this should not have happened. We should have known better back then. Then we get things like this. This is probably JavaScript, I guess. Removing this next bit breaks things. I don't know why. The problem here is a little bit the code, but also the comment. Leaving a comment about why something doesn't work is not really good enough. Like, if you've got an issue in your code where you don't actually understand what it's doing, surely it's our responsibility to work out why it's breaking and to actually make sure that it doesn't break and to get rid of that comment in the first place. But again, we've probably all seen this kind of thing. I can confidently say we've all seen that because everybody put their hand up saying they've experienced legacy code base issues. Oh yes, and also I should never be greater than 31. That apparently is an issue in this code, though. I mean, you could argue that get days of month might be 0 index, in which case it should be no greater than 30, but it should never be greater than 31. Not on this planet, anyway. Maybe this is code from another planet. This is probably one of my favorites. Byron is a very clever person. He's written, if you need to change this code, talk to me first. That's a comment from 2007. There's a comment in from 2019 saying Byron hasn't worked here for years, but also note how this person hasn't put their name to it. Can anybody tell me what this does? No, exactly. Just in case you're curious, it basically goes through and makes sure your password is at least 8 characters long and up to infinity long. If it's only got letters, then it's a weak password if it's less than 8 characters. Otherwise, it's a medium password. But if it has symbols, then it's a strong password, and it just returns that string. Surely there are better ways of doing that so we can actually read the code and understand what's going on. I've explained that piece of code like 20 times now, and I still don't have to refer to it and stumble over it. And then how about our documentation? Do you want to develop on this application locally? Okay, so you've got to download the database from Dropbox. That's cool. You need to install MySQL. Who's installed MySQL recently? 2 people. Are you database administrators or in sysops or something like that? No. I would love to find out why. Because nowadays, mostly, we just spin up a Docker container, we define a YAML file somewhere, and we just start our application, and there's our database. So to find this kind of documentation, we're all a little bit like, which version? What server do I run it on? My favorite bit is enable magic quotes on the API application. For those of you who do know PHP, you're all shivering in your boots right now. Magic quotes was this brilliant thing that automatically would escape strings that came in from user-generated content so that it wouldn't cause issues in your application. Can anybody name that one string escape function that applies to everything? To HTML output, to email content, to SQL queries? There isn't one. So the beauty of this was that in your application, especially if you wrote an application that could be hosted in multiple environments that you didn't control and you didn't know this switch was on, is you would have to have code in your code to determine whether or not this was on, so you knew whether or not to unescape it again, so you knew what the original data was, so you could re-escape it for the destination you were sending it to. Worst idea ever. But this application requires it. Also, it only works on Windows 7. So these are the kind of things that still exist. Hopefully, who's still working on applications that have this kind of documentation? Oh, crikey. I was hoping that would be a 0. We had like 5 hands. I'm sorry. There is hope. let's look into some of that hope. So in order to work out the kind of things that other people have done, because it's always nice to have your own ideas and opinions and experiences, but I thought let's go and find an actual case study of somebody who's been through the process of taking a legacy application and bringing it into the modern DevOpsy era. So there's a Polish software company called Monterail, and that's the blog post that I'm referring to in here. And they did a case study for one of their clients, CoolLeaf, who are basically like an HR management as a platform service thing company. And they found they're working with a very legacy application that they needed to try and modernize. And some of the things that came out of this was that what they discovered was that legacy issues happen in every code base. The legacy code is slowing the project down, the team working on that particular product has changed, and the technology and practices used have become outdated or obsolete. Essentially, every time you work on this application is getting bigger and scarier. And the reason why they said it happens in the life cycle of every product or project or code base is that if you start a greenfield application today, in a year's time, it's going to be legacy. Unless you're continuously reevaluating what you did at the beginning of the year and modifying and updating it and bringing it up to speed, and when the latest deployment best practices change, you change your practices around that, everything is going to decay. Now, when it's a year or 2 or 3 years old, it's probably not an issue because the decay is slow. But over time, you're all going to have an application you start today. It will also be treated as legacy code. So they thought this is not actually an issue of just legacy code. This is an issue for every application that lives longer than a few years. Time for some more water. So you end up with a monster app that becomes difficult to handle. So what they found was that refactoring legacy code is extremely time-consuming. I think we can all agree with that. You're going to end up with an app that's unfit for release for months or even years. The reason for that is, as you're refactoring, you're changing the code, and it's not actually functional anymore. So you've probably got 2 applications going at the same time. You've got the one that's actually running, and then the one that you're refactoring. And depending on how you approach that refactoring or rewriting process, there are going to be periods of time during which the new code isn't actually doing what it's supposed to do. It's still going through testing and development. So you're going to have that issue. You're going to end up with an app that's unfit for quite a while. And over the application's life cycle, as they worked on this completely, they found that the application did actually still have some good ideas, but also had some really, really bad ones. Remember Byron? That regular expression? And it's the bad ones you really need to focus on. They took an approach they were going to do a complete rewrite, which meant that they basically had to touch every line of code again. But what they focused on was the really bad code. So I guess the thing we can learn from that is that when we're taking the code that we've got, it is going to be a slow process as we rewrite that. And if this is a project you're working on that is going to have multiple years ahead of it, if it's not just a project that you've inherited and has gone into maintenance mode while it's deprecated or completely rewritten, and I've been on a project like that, and it's painful because you really want to fix things, but there's no point because you're about to throw the whole code base out in like 4 months' time. But if you are going to be attacking that code and bringing it up to speed, attack the pain points first. One of the biggest problems they faced is that they had lots of dead code, and that can be really hard to find. It's not easy to go through and delete code and then see if the application is still running. There are tools that will help you find dead code. Static code analyzers are going to be able to go through and say, hey, this block of code has never been hit before. And that's going to give you a bit more confidence. You can go through and delete it and then run your test suite again to make sure that everything's still running. And theoretically, if the static analyzer is doing its job properly, but of course, you need to put that into a testing process as well. So finding this dead code still requires you to go through extensive testing to make sure you're not actually getting rid of something that somehow was being used. An example of that is I found an application, again, in PHP. Nothing bad about PHP. You could do this in any language if you tried hard enough. It was basically dynamically including files and executing functions in that file based on variables that were defined at runtime. Therefore, the static analyzer wasn't able to determine that that particular file was being loaded. Right? Imagine trying to debug that one. Don't do that. Lots of duplicated code. This is not necessarily as much of an issue. The problem with duplicated code comes, and I'm sure they would have faced this as well, is when you get functions that do almost the same thing, but they're actually quite different insofar as the code is written differently. It might have been written at different times by different people, but it ostensibly does the same thing. It might have a different signature, so it might take different variables in, but you could probably combine that into one. The problem is finding that one, finding the two functions that are so similar. You might argue that, well, if it works, then why bother? But imagine coming to a point where you need to change the functionality and you find that one function that does this thing, and you change the functionality, and you test it for your purposes, and it's like, yeah, that's great. So it passes your tests. So you put it into production, and then something else doesn't break, but it does things the old way, and you're like, hang on, I updated that code. So suddenly you've got this issue going on now where you don't know what's happening between the left hand and the right hand. So finding that duplicated code is an issue. But the application did all work as expected. So they decided to, let's leave it on that one for a little second longer. They decided to go through the process of defining what their next steps were going to be, having analyzed the code, seen what the issues were, realizing that the application did actually do everything that it was supposed to do. There weren't actually any bugs in the system. It just wasn't very well crafted, which meant that they weren't able to scale the application. They weren't able to push it out through deployment processes to scale across the cloud. It was a manual deployment process, all of these kind of things. They had lots of dependencies on the code as well, which meant that they had to make sure that all those dependencies were not going to cause an issue when they rewrote the application. So there was a lot of documenting exactly what was going on under the hood and really understanding what that code was doing. So they decided what they were going to do was say absolutely not adding any more dependencies at all. So they used gems in theirs, replace that with whatever dependency or module functionality you have in your language of choice. But they decided they're not going to add any more dependencies because they had a dependency hell already, and they didn't want to make that even worse. Interestingly, I'm seeing there's a movement in some areas, some people I'm talking to at the moment, who are actually trying to get really down on their dependencies, make it as small as possible. One of the reasons behind that might be the supply chain attacks that we've seen of recent years. There's always the most hilarious leftpad example. That is anybody not familiar with leftpad? A couple of you. So there was a npm module for JavaScript, which all it did was pad the string to the left, and it was turned into a module that you could include. Brilliant idea. The maintainer then stopped maintaining it, and I don't remember the story exactly, so I might have this slightly wrong. But from memory, somebody took over the maintenance of the project and then decided, oh, no, I think in this case, the maintainer actually got, this is being recorded, isn't it? I need to mind my language. He got very angry with certain people and decided to throw a table flip hissy fit moment and deleted the package. And you've probably seen the XKCD picture. I should actually put this into the slides. You've probably seen the XKCD picture where you've got all these building blocks and they're all stacked on top of each other, and then there's this tiny one on the corner and there's an arrow pointing to it. And depending on what kind of a statement the person using this image wants to make, that is like the Achilles heel. And I've seen where it just says left pad. Because as soon as that disappeared, half the internet just collapsed. Because it's not just you using left pad. It could be a dependency you're using that uses a dependency that uses a dependency that is dependent on left pad. And as soon as one of those little fundamental pieces of community code, it's not even your code, one of those disappears, your entire stack falls down. So anyway, I go on side tangents every now and then, rein myself back in. So they didn't want to add any more gems. They decided to redesign the architecture. Then they realized there wasn't an architecture, so they decided to design the architecture. And this is another problem, is that a lot of applications start as greenfield, exciting projects. It's a proof of concept. And then somebody up the chain is going to say, make it live. You're like, you know what? This was not designed to be live. It was designed to prove a point. They're like, yes, you've proved your point. Now make it live. You're like, no, I really shouldn't, because there are so many issues with this code. It's okay, we'll fix it in prod. No architecture. They hadn't thought about it. So they decided, okay, let's actually design an architecture around this application and implement that in the rewrite or the refactor. They had one app and they decided to split into many. This can be a really useful way of breaking down your process of going from legacy to modern app. And I'll touch on it in a bit more detail later. But essentially, and it does depend entirely on the application that you're looking at. If suitable, if you break it down into smaller chunks, it's a little bit like a service-oriented environment kind of an idea that you can apply not just to services. It could be many different architectural styles. Breaking it down into components or even their own applications can be a really good way of making your life easier if it's right for your application, and it isn't always. Basically, the kind of ones where it isn't is monolithic applications where everything is really so connected and independent on each other that to break it out into its own component doesn't actually make architectural sense, and that's really only something you would know. But if you want to talk to me about your architecture after this talk, and we can go through that and work out whether or not that's right for you. So their plan of attack was that they were going to remove all the unused code to start with, just to make it easier for their developers as they were going through to have like this context of what the code is doing. If you have to focus on what code is doing and then you realize it's never actually executed, you're wasting your own brain cycles. They were going to clean the remaining code so it was actually readable by humans. Often, and this isn't a bad thing, in the olden days when I were a lad, like let's think early 2000s roughly and before, code was written optimized for the computer. Because computers were slower, we had less memory. Nowadays you can take a monolithic application that is not really designed for performance and throw it at a cloud platform as a service, and it'll probably deal. It'll probably be okay for 90% of all situations, and for the 10% you can probably work that out and then just focus on optimizing that for the algorithm or for the processor or the runtime engine. But back in the day, we didn't have that luxury. I sound like a really old man. We didn't. I need to change my attitude. So we would be writing for the computer, whereas nowadays, because we are able to just throw anything we want at the computer, we're writing for the next developer, not for a computer. So it makes more sense to break the code out in a way that's easily understandable by a human brain. And this code obviously hadn't been, and that's one of the things they were planning on changing. And they were going to use a repositories concept for the way they did their domain architecture, basically. It was a small team, so they decided to have this done by one person, which I'm not entirely sure that's a good idea, because basically this one person was siloed away, and this work had to be done and completed in one go before anybody else could actually then touch any of the models and the data. And so they were working on the functionality without being able to really access the data. I believe they used a mocking system to make it easier, but then of course, when you cut over to the actual repository code that they used, there's going to be like that integration clashing kind of a scenario. So they had issues with making it easy for developers to use the new way they were going to be storing the data in their databases. And I think that perhaps if they decided that the team, I think it was a team of 5 or 6, if they'd all worked in tandem on the repository concept of how they were redesigning their application, while also working on the features that then connected to that in order to be able to get data out of the database, they might have had a smoother path of it. But of course, I wasn't part of the team, so it's pure conjecture. But again, there are many ways of doing this, but breaking it down into these components internally, even if you can't split your application into like vertically separate applications, break it down internally into sub-projects, the repository thing by itself, and then, I don't know, the admin dashboard, and then the front end, and then the user model, and like breaking it down into chunks makes it much easier as a concept in your head to attack these piecemeal. And lastly, they decided to use a lot of abstraction layers. This can be useful in a rewrite, because if you abstract things out, then you're able to actually use that abstraction layer to point to different services. And this can be, like I was saying before, you can have your application split into multiple smaller applications, or internally within the application, you can have it broken down into functions. I don't mean functions as in public void function, blah. I mean functionality groups. So again, with the repository, you could have had an abstraction layer and said, okay, for now, we're going to be pointing to the mock. And then later, we're going to point to the actual database. And by abstracting that part out, it means that you don't have to change the code that depends on the data itself. And you can do the same thing for all the other models and all the other functionality abstracted out, so you can easily then swap out the underlying code that performs the function without the rest of the application having to change. All right, so anything missing from what they talked about? That was a lot of information, and I'm kind of out of breath. and you're probably glazing over. So we're going to get into something a bit more exciting. But one of the things they didn't talk about, a lot of what they were talking about was all manual stuff. How much of this can we automate? The article did say that they wanted to try and get as much test coverage as possible, but they didn't really go into their testing process, and maybe that's because they just didn't document it in their blog post. Again, I wasn't part of the team, but I imagine they would have had test suites in the background. But it'd be nice to know how they did that so that we can learn from that. So we'll have a bit of a think as well about how you can test these things by breaking it down into the abstracted groups of functionality. Again, you can functionally test those separately. You can do integration testing, whereby you don't actually test the code itself, you just test that the output is the same. And we'll touch on that in a little bit as well. Yeah, so the most important thing is to provide the highest possible test coverage in order to test the changes immediately. That was from their article, but they didn't really allude how they did that. So that's something you should also put into your migration plan as you're working on this change from your legacy application. So again, I don't know their code, and their case study is a fairly limited overview in terms of what they did. I'm sure there are bits missing from that. And I certainly don't mean any of what I've just said as a critique. Not part of it, can't comment on what actually went on behind the scenes. There are alternative ways you could do it. Maybe that wasn't right for them. I'm sure they chose the path that was right for them. And I think it was an interesting case study to look at how they broke that down. So one of the things that they mentioned, though, was that they wanted to clean their code. And you might think to yourself, well, why would you clean code that you might never change? Because they were going to clean the entire code base. And there's this thought, and when I say clean code, I'm not referring to that guy who wrote a book about it. He seems to own the idea of that name. That's certainly not what I consider to be clean code. There are certainly aspects of what he talks about that are great. But clean code, as a general philosophy, is basically around maintainable code that's easy to read by humans so that you can spot things when you're reading it. It's easier to pick up again in 3-6 months' time. Especially that situation where you pick up a file, a piece of code, and you're like, what on earth is going on here? And you're thinking, I really need to work out how this person was thinking when they wrote this line of code. So you go into the command line or your Git tool and you do a Git blame, or if you don't like to be too antagonistic, a Git praise, and you find out who wrote that line of code, and you're like, I'm going to go and talk to that person. And it was you? Yeah, anyone else? Yeah, okay. So is it worth cleaning all the lines of code if you might never touch them again? So there's an interesting analysis here of, this is actually the source code for SonarQube. It doesn't have to be SonarQube, it's just a graph that I found, which I thought was interesting. And it's basically code additions in terms of line of code over time. So you can see here at the beginning in 2010, when they first started writing their code, they wrote like just under 0.4, I'm guessing, million lines of code. And that was the original application. And it kind of grew a little bit, and then you can see that in probably around about 2013 here, there was a big drop. So there must have been a rewrite of some sort. Got rid of a whole lot of code, put in a whole lot of other code. The purple lines are the additions, so there was new code coming in, even though the total lines of code in the application dropped. And this is a really interesting way of looking at your code. And I would recommend, if you have access to a history, whether that's Git or any other kind of source control system, if you have a legacy application, have a look at this graph, because it can be quite telling. Because every graph will be slightly different. And I've got another graph in a second that talks about the half-life of code. If we look at the half-life of this code, so the halfway point on the right here, this is back from 2022, you can see that everything above there is new code since when yellow started, which was 2018. So half the code in the SonarQube code base was written in the 4 years preceding 2022, up to 2022. So in 4 years, they lost half their code, or they added half more code, whichever way you want to look at it. And this half-life is a really interesting way of looking at your code, because if you have a really slow half-life, then maybe it's worth looking at more than just the code that you're changing to clean it up, because that code is going to last for a while. If you've got a really short half-life, though, then what's the point in reading code that could disappear in 1, 2, 3, or in this case, 4 years? It's a 50-50 chance of that line of code disappearing, so why spend your time cleaning it? So the average half-life, do I get the, there we go. This is the slightly more interesting graph. This is generated by a guy called Eric Byrne. There's the URL down at the bottom if you want to read his blog post. He basically looked at a whole load of repositories on GitHub and defined the half-life of an average application. And it's not actually an average application because it was based on, I think, a sample of around about 20. Did I make a note of that? I didn't. Around about 20 or 50 open source projects, including the HTTP daemon, Rails, Node, Angular, and then a whole load of others. So you can see that the average half-life here is 3.33 years. So every 3 years and 4 months, half of the code of one of these average open source applications disappeared. If you look at this one over here, that was Angular. I think that was Angular. That was Angular. They had a half-life of 0.32 of a year. So every 4 months, half of the Angular code disappeared. Now, the date of this is not on there, I don't think. The blog post was in 2016, so we can assume that it was a 5-year span. He's probably starting to look at about 2011 there for the starting point. So that's probably when Angular first started. And in a new application, there's going to be a lot of churn, and that's fine. Some of the older applications along the top there, the slowest one is Apache HTTP daemon, and it's been around for decades, right? That's got a half-life of 5.38 years, so a lot slower. Now, in the case of Angular, I would argue that if you were going to jump into that code and it wasn't written in a clean way, that you'd probably only want to clean the files and the stuff that you're working on, because the other stuff is almost definitely going to disappear within a year. If half of it disappears in 4 months, it's definitely going to be gone in a year. And in fact, if that's Angular 1, it is gone now. Anyway, so imagine cleaning all your code now. In 5 years, 63% of that is thrown out. So that's this 5-year chart that he put up. That's a lot of code that you'd be spending time on now that is essentially wasted if you never look at it again. So let's take all these concepts, the idea of managing your code and breaking your application down and putting in testing procedures and working out what you actually need to clean and what you don't need to clean, and see whether we can get some kind of a DevOps flow in here to help us out. Because if you're like me, most developers are lazy. If we can make our lives easier, we will. So let's see if we can use tools to make our lives a little bit easier. First thing we need to do is decide on whether we're going to go on the refactor or the rewrite route. If you're going to be doing a rewrite, then essentially you've got 2 projects. You've got the maintenance of the current one, and you've got the complete rewrite. Who here has gone through a complete rewrite scenario? Keep your hands up if you would recommend doing it again. Interesting. So we had about 15, I would like to say, put their hands up at the beginning, and then there were about 7, so maybe half of the people kept their hands up. I've been on a project that was a complete rewrite. I was actually brought in to run a team of contractors to maintain the old application, because of course the in-house development team wanted to have the fun Greenfields project. I totally respect that. I was brought in to maintain this project, and then over time it was just like a flick the switch. It was a cut over to the new application. In that particular case, the plan was to do it in 6 months. A year and a half later, I left, having completed the project successfully, or at least the maintenance of the old one successfully. They can have a tendency to run over. And again, we were talking at the beginning about what are the implications of that lag between now and when you're ready to roll. The time can be a big factor in that. And if your application, this application was an e-commerce site, so it didn't actually matter because there wasn't any new functionality coming through. They just wanted to re-architect. But if your application has a lot of feature churn, or ideally mostly additions, remember that if you're going to do a complete rewrite, that's going to be really hard for you. If you go for the refactor method, taking piecemeal items of your existing legacy code and updating them while you also have the ability to add new features. And maybe you can prioritize what old code you're fixing because they are required to be fixed for the new features, then you're still able to get that new functionality out to your customers. So even though a rewrite can be fun, even though Greenfield projects are the best thing ever, if the application you're currently maintaining has a really active user base, and you don't want to use those users and they expect updates and new features and additions to the application that you're working on, I would highly recommend considering the refactor approach. just because it gives you that flexibility to stop on the refactor and start on the features, stop on the features, start on the refactor, and keep that going to your customers, because if your customers get annoyed, they'll go somewhere else. There's no point in having the best Greenfields app launch in a year and a half if you don't have any customers to use it. So have a thought, think about that one. I'm going to continue on the basis that we're doing a refactor. So I would recommend taking your application and containerizing it. It's probably the simplest first start I would recommend. Main reason for this is, especially because I come from PHP, MySQL kind of a world back in the mid-2000s, trying to set up your local development environment to run that is fine, but then when you have multiple versions of the application running, it can get really confusing with the different environments, like whether it's the variables or the versions of applications or libraries that you're using. So containerizing it early means that it's going to be easier for you to work on. It's also going to be easier when you bring new people into the team for them to ramp up. If they can just run a containerized version of your legacy application, it might take a little longer to get that container working for that legacy application, because it can be complicated to get old architectures working. But I would recommend investing that time so that it's easier for you in the future. It's a chunk of work up front that makes your life easier down the line. Yeah, so you don't need to set up each dev environment for one particular environment. Basically exactly what I've just said. You can build and destroy applications on a dev machine as part of the lifecycle and make it possible for developers from any machine. And that's the other thing as well, is you could even then use things like Gitpod or GitHub Workspaces, I think it's called, and you can work from anywhere. You can work on a really slow internet connection from Peru while traveling and still be able to work on an application because it's now containerized, it's in the cloud, it's easy to work on. Anybody want to work from Peru? Well, I'm not alone. Excellent. You can then use those containers for scaling. So if you've got your, and again, this depends on your application. Not every application scales horizontally through containerization because there are implications around databases. Just if you can isolate. If the application can be isolated to a particular use case, maybe you have it broken down into multiple organizations. So you might have, I don't know, 10,000 customers, and each of them works in a siloed environment. You could probably do 10 servers with 1,000 customers on each. If you run Facebook, you probably couldn't do that because everyone's talking to everyone. So again, depends on your application, but containerization does make it easy for you to then scale if you need to. So a lot of issues with legacy applications is that scaling doesn't really happen. You can also move each of your services, if you're breaking things down into separate applications, as the Cool Leaf project was doing. If you containerize each of those, it makes it much easier then to scale that in a more refined way. So say, for example, you've got an API, a web application, and a database container separately, and they're all working together. But you need more API and more database, but the web application isn't actually hit that hard. It allows you to scale in interesting ways, even though it's still a legacy application. Again, depending on your architecture and whether that works for you. Use orchestration for reliability. So again, this goes back into the containerization and making it easier for people to jump in. We do this for new projects already, so why not try and get your legacy application into that? It's going to give you the faster onboarding that I mentioned, and it's going to give you that common development environment. And this is something that I really struck on a lot of issues with when I was working on the maintenance project for the rewrite company, is that they had decided at the beginning not to go into a containerized method. Everybody basically had all the applications running locally on their bare metal laptops. So one of the first things I did was move them over to, in those days, it was a VirtualBox machine, so it still had the full GUI interface, and I had their IDs and everything installed, but it meant that on the one occasion when my computer completely crashed, I was up and running again within 45 minutes, whereas originally it took 2 days to get a new developer set up on an application. So common development environments are a really good thing. Speeding up deployments into testing and production. Same kind of thing. If you've got a fixed environment that you can just deploy somewhere, you can deploy it to a test machine. Done. And then ease of rollback. So if you're deploying through containerization, where you can just say, okay, let's put this into test, and it's not working, it's really easy to go back to the previous version. Whereas before, you would probably have to do a git rollback on the development server and then make sure the database changes were unrolled, and all these manual steps I remember we used to have to make. So automating as much of that as possible. So here's a little bit into that idea of having multiple implementations of a piece of functionality running at the same time, and a little bit of that abstraction stuff we were talking about before. One thing I've seen work really well is testing your old and new stuff at the same time in production. So you rely on the old code because you know that works, and you verify the new code in a production environment. So you actually deploy it to production, and it is going to run, and it's going to look at your data, but it's not going to change your data, and it's not going to change the results or the output back to your users. You automate all the deployments, which that's a given, right? API gateway you then use an API gateway to proxy the requests that come in to both your old application and your new application, and then you log to detect any anomalies. So let's put that into picture form. Request comes in, and it goes to a load balancer of some sort. It can be a simple proxy that just makes 2 requests from the one, or it can be a full-on load balancer, depends on what you want. It doesn't really matter. You send that request to the legacy application, and that legacy and the API that you've just rewritten as well, the new version, the new code that you want to deploy into production, but you haven't tested it. You've tested it in all the stuff before production, but you now want to make sure it actually gives you all the results you expect in production. So you send the request to both. The actual response that goes back to the user from that request comes from the original application, because you know that's good. The code might be rubbish, but you know the result is good, right? Because it's been running for a while. At the same time, you also log the output from both the legacy application and the new API that you've written, and then you can run analysis against that. Did the results match? And if there isn't a match, then that's what you flag into your logging system. You pick that up, you go through, you work out why not, you fix the code, you redeploy. So you're actually able to test with production code in a production scenario, like your actual users using it, not you getting a copy of production code and running your own test suite. You're getting real-life usage testing of your new code, and you're able to detect things before it goes into actual production that is used by the users, if that makes sense. And then adding IDE developer tooling. So benefiting from shift left. Who loves the term shift left? Nobody? No, not me. It's a nice concept, right? Move as much of the stuff to the left side of the development process so you detect things early. Conceptually, it's a nice idea. I'm not sure about the term. Automatically find all the unused code, use tools to monitor the new code that comes in. So again, we were talking about what code do you clean. Just clean the new code that's coming in, because that's likely to be the code that somebody's going to read in the future. If somebody in the future reads code that hasn't been cleaned, it's because it hasn't been looked at for years. And then they clean it, and then the next person gets the advantage of having that clean code. So clean it as you modify it. And obviously, any new code that you write, make sure that is maintainable and of good quality and readable and all those kind of things. It allows you to identify vulnerabilities more easily in near real time. In fact, that's not what the slide says. It says identify vulnerable dependencies in real time. There are plenty of SaaS tools out there. Some big companies who I could name, who you're probably familiar with, who will go through your code without even executing it and say, hey, there's a dependency over here you're relying on. There's a CVE, there's a vulnerability that we're aware of. You should look into that. So use tooling to make sure you're not relying on any of these potentially vulnerable dependencies, and then be aware of platform configuration concerns before you first deploy. So especially with moving to this containerization, if you're actually using orchestration, if you're defining YAML files that tell a system how to build it, make sure that's secure. The number of times I've seen somebody deploy something, and there's an S3 bucket that hasn't been properly secured, and there's publicly identifiable, personally identifiable information going into those S3 buckets. Default S3 security, I mean, default is somewhat secure nowadays, but a lot of people treat it like it's security through obscurity because you have to guess the long GUID. It's not secure. I remember reading just recently, I think a month ago or so, that somebody had managed to break a whole load of S3 buckets just by brute forcing that GUID and had some success in getting some fairly personal information out. So yeah, make sure your orchestration is done in such a way that you're actually creating a secure environment. And avoid accidentally committing secrets to your code repository. This is something I see in legacy applications all the time. The API keys are hard-coded into either an ini file or something else that's submitted to the repository. There are a lot of tools now that will detect that once it's in the repository. In my opinion, that's probably a little bit too late. One thing I do like about Twilio, anybody here use Twilio? A couple of you? I've written a couple of demo apps in Twilio, and I've committed them to my demos GitHub repository. And they're always API keys I don't care about because it's limited. But Twilio don't know that. So they actually have an agreement with GitHub, and I believe a lot of other SaaS providers do as well, that if anything is committed that looks like a Twilio key, a Twilio webhook or something gets hit and gets reported, and they will actually shut that key down. They will close your account and send you a nasty email saying, please explain. So try not to get into your repository in the first place. And get test results right on your desktop. Now, Sonar Lint, which I mentioned before, one of our tools, completely free and open source, will do some or all of those things. You've got various other tools out there as well. Have a look at Sneak, for example, for looking at dependency, vulnerability, supply chain issues. It'll have a look at your dependency files and find potential CVEs. And basically, this is what Sonar Cube looks like when you're using it, which is looking at the overall code. You might have a whole lot of issues, but when you look at the new code, there might only be 4 bugs. So if you fix those 4 bugs, even though the old code might still have vulnerabilities, you don't really care that much because, well, care that much. You should care about vulnerabilities, obviously, but if the code is working, and it's not actually a bug or a vulnerability, if it's just a lack of cleanliness or readability, then you don't need to worry about it too much. So let's dive a little bit into clean code in the last 4 minutes. So this is Donald Knuth. He's a computer scientist and mathematician, professor emeritus from Stanford University. He was kind of named the father of algorithms. He's an early contributor to what we see in computing nowadays. He said that programming is not about telling the computer what to do. Programming is the art of telling another human what the computer should do. Again, going back to what I was saying before, we should be coding for the next person who reads our code, not for the computer itself. So basically, programming is storytelling. But imagine if you're trying to write a book with a friend, and this is what the book currently looks like. He's actually started on the binding already, even though you don't know how big the book is. The appendix and the thank you has been written, as has the summary, but the content isn't actually there. In fact, some of the content has been written, but is kind of buried inside the appendix. And it's your turn to write your chapter. Sounds like fun, right? So a couple of stats for you. I want you to leave with a little bit of information that if you wanted to go to your manager and say, hey, we should change our ways, here's an idea, because often getting manager buy-in can be a bit tricky. So I'm really going to quickly skip through these, but if you want to ask more about this afterwards. So 41% of your week, apparently, is spent working on bad code. There's a link down at the bottom there. Take a photo of that if you want to get the citation source. But essentially, we're spending about 17.3 hours a week looking at bad code. At the same time, this was a study done on a number of people, so it wasn't based on an actual code base or a company. It was based on a study of people doing coding in a set environment, so take these stats as you will. But essentially, we've got reading code, navigating dependencies, and searching for names. This is kind of working on existing code. Whether it's good or bad, you're just looking at existing code, and that comes to 42% of your time. Meanwhile, you've got editing code, and that comes to 16% of the time. So reading versus writing, you're spending 3 times more time reading the code than writing the code. Also, interestingly, on the left-hand side there, handling interruptions, 22% of your time is wasted handling interruptions. If you want an excuse for work from home, there it is. So we've got 58% of the time working on any code at all, reading or writing. Right? 58% of the time on any code. We've got 41% of the time spent on bad code, which means that it's just 7 hours a week are spent on new code. Does that resonate with people? Yeah, I'm getting a couple of nods. So this is what we're looking at the moment. You've got the 41% of bad code, 17% of new code. Imagine if you could halve the amount of bad code, the amount of time you're spending working out what on earth is going on, reading the documentation that has been written by Byron, all of those things. Imagine if you could halve the amount of time we spend on bad code, we'd actually increase the amount of time we spend on good code by 120%. Sounds wrong. It should be like if one gets halved, the other one gets doubled. But that's what I love about stats. So you've got a 20% increase on productivity because you're spending some time on cleaning stuff up, but the gains are going to be huge. So if that doesn't persuade your manager, nothing will. So in summary, legacy systems do still need DevOps. Automation reduces legacy pain. Strategic refactoring or rewriting is something you need to consider. So you want to, what's going on here? You want to reduce complexity through that rewrite. You want to fail faster. If you're rewriting completely from scratch, you're not going to fail very fast. So refactor, get things out as quickly as possible, test them in environments where you can get information as quickly as possible, fail early, shift left, fail early and get your application working better than it was before. Enable DevOps enhancements, so being able to transition to a modern system in piecemeal. Let's just skip right to the end. I've given you a business justification. We've talked about continuous improvement, and we want to enhance the developer onboarding process. So all of these things kind of can be done even with legacy applications. I hope that was a fun whirlwind tour for you. I'm being flashed at down here. Time's up. So thank you for your patience with a few technical issues at the beginning, a small delay, and for sticking around for the last few minutes. I'm Ben DECHRAI. I hope you've enjoyed the talk. Please come and chat to me. I'll be outside for the rest of the day, or in fact in here until I get kicked out officially. So thank you for your time.